Welcome, YWITers. Welcome to the A Picture's Worth 1,000 Jobs session. This session is for everybody on here who is just curious about, knowing what working in technology really means. If you're in high school or middle school, you love to think ahead and find out what you could study to have a good career in tech. This is the right place to be. Or if you're on the other end of the spectrum where you don't really, enjoy programming so much, or maybe you're not sure if this is the right spot for you, we will also talk about how your non-tech interests and skills could still be applied into the evolving world of technology. So with that, I'd love to stress that tech is everywhere and tech is in everything. So with that, let's begin, and thank you all for being here. I want to say quick notes that if you do have any questions while you're listening to us, while you're taking part in the session, please hit the Q&A option over there and just type in your questions, and we will try to get to them at the end of the session and answer all the questions that you have. All right, so with that, let's begin. Chuck, you wanna kick us off?
Sure, thanks, Apoorva. So hey, my name is Chuck Heinley. I'm a software engineering manager here in our core software group in Pittsburgh. And it's great to have you all here, and appreciate you taking some time today to join us. And I'm really excited to be a part of this team in this session. We'll be giving you an introduction to some of the careers in technology, and we'll give you kind of a short overview of our lives as software engineers at NetApp, some examples that include the various roles that you could consider for jobs in the future in technology. And there's so many options to choose from. It makes it exciting as well as confusing. We understand that. We hope that this session will give you some ideas as you look forward to your studies and eventually in your career path. And one thing I wanted to mention as we're getting into this, as we get started, 5 years ago, my daughter Alex attended these Young Women Technology sessions. And she kind of came in unsure what it meant to be a software engineer and what it meant to work in technology. And she definitely did not know what she wanted to study for in college or for her future career. Now, I'm proud to say, though, that she ended up using this Young Women Technology session as a springboard into her study in computer science in college, and just recently was hired by a company in Pittsburgh to be an application developer even before she graduated. So it's really worked out for her. It really turned the corner, and it may all seem far off, but your experiences now, especially with these sessions, will shape your upcoming choices in your academics and your career. So that said, I'll get through some of the overview and introductions quickly so we can spend more time on the good stuff. Feel free to ask questions as we go along, and we'll hopefully have enough time at the end for even more questions you may have. So as far as NetApp, I don't know how much you've all heard in the earlier sessions, but we're a software and storage services company. It was originally founded in 1992. It was called Network Appliance at the time. It was eventually shortened to NetApp, which sounds a lot cooler and less like a toaster. So I think we're happy about that. Our headquarters are in Sunnyvale, California, which some people know as Silicon Valley. It's near San Francisco. But we also have offices around the world, including an important engineering office here in Pittsburgh, where we're all from. A lot of our focus at NetApp is on data storage, and I think you probably are all familiar with what data is. Data can be your homework that's stored digitally, a photo of your family that's in Google Photos, or an iTunes song. And I'm sure you've all used things like iTunes, where that music that you download is stored somewhere in the cloud, and the cloud is made up of computers that store music, right? So you probably never notice with iTunes that each time you try to download music, you would almost always get that song, right? So unless you're having Wi-Fi problems at home, you should be able to get to the song. And that's because Apple keeps multiple copies of that song on their computers and their computer disks within their data center. And if one of those computers that store that song goes down, then there's other computers that can allow you to download it. And that's what NetApp software does. It helps companies like Apple make sure that their customers can get to their data, even if one computer has a problem. So, most of the time you can download it at midnight, at lunchtime. It's fast, and you don't have to worry about where to go get a song if you can't find it in one location. Apple and NetApp helps to make sure that's easy. And it may sound complicated, but it is an example of what our engineers build for customers and for people like you. And if we're doing our job right, you don't even notice any problems that are occurring behind the scenes, and that's what we try to do. So companies like Apple, Google, Microsoft, banks, oil companies, the US government, they all use our software to help manage all of their data. And we're happy to answer any questions as we go further, if you do have them about NetApp. Okay, so a little bit about me. So there we go. So I went to the University of Pittsburgh, where I studied information science and computer science. I spent my early career as an application developer and engineer before I moved into management of engineering teams. And I spent most of my career in the storage technology industry with NetApp, but was previously at positions at both large companies and small companies that covered a lot of different industries like retail pharmacy, manufacturing of fiberglass, transportation for railroads and subways, cell phone tower companies, and bioinformatics companies where we built software that analyzed microscopic images looking for patterns to help scientists and researchers. So I've kind of been all over the board and used my my college studying and experience to leverage technology in many different ways. And I've had fun along the way, and many of these experiences have provided me a journey to what I now love doing here at NetApp. So Denise, I'll turn it over to you.
All right.
All right, thanks, Chuck. My name's Denise Ombres, and I've been working at NetApp for about 10 years. Overall, I've been working 25 years for 6 different companies throughout that time, all involved in the tech side of the companies. I started out getting my master's from Pitt as well in computer science and math. In high school, I really liked math, and so I looked for a major that I thought I could use my math skills in. Computer science looked like something that I would really enjoy. I'm really passionate about quality. That's my focus at NetApp. I try to ensure that things work. And so as Chuck was talking about, iTunes and being able to download, my job is to make sure that you can download that and you can get your music or whatever data you have stored it in the cloud. I have 2 children. I have a senior in high school, and he is also interested in pursuing a math career. He's applied to the statistics department, and he's looking to focus in the data science area. And I have a daughter who's a junior in college right now, and she's in the biomedical field, but also very much involved in technology.
Awesome. Hello all. So I'm a software engineer in test at NetApp. I've been an SET for about 6 years now. I graduated with a master's degree in computer science from USC, and before that I got my undergrad degree in information sciences and engineering back in India, which is where I'm from. Unlike a lot of you, I'm so happy to see so much interest in technology from such a young age. Unlike a lot of you, I wrote my first line of code while I was already doing my undergrad degree with CS as my major. Needless to say, I did not do very well in that first class, and I really thought about, is this something I really wanted to do? Is this, what if I'm not good at it? What if I'm not worthy of it, right? But I'm here now. It's been 6 years and I've been doing really well. I went on to do my master's. So I just want to say, if you feel that way, you will learn and you will pick up these skills as you go along. So at NetApp, I'm also an active member of Women in Technologies. It's an affinity group that we all support each other and encourage each other to do well. And I'm also the Pittsburgh site lead for one of the Pittsburgh site leads for Young Women in Technology workshop today. So great to have you all.
Hi everyone, I'm Joe. Like Denise and Chuck, I also went to Pitt to study computer science. I got my bachelor's and I just finished my master's in computer science at Pitt. Before I went, right now, and for the past 4 years, I've worked at NetApp. I'm a software engineer. All 4 of us are on the same team and we work together every day. Before college, I got my start in computer science by taking AP computer science in high school. Funny story for me, I actually didn't want to take computer science at all. I wanted to take an accounting class as my gen ed in high school, and the guidance counselor said the class was full and they just picked a computer science class for me and threw me in that instead. And I found out I liked it, and then the rest is history. I don't have any kids, but I do have 2 cats, and you might have heard one chiming in earlier.
Awesome. All right. So let's get started, but before we get into the meat of the session today, we will just talk about, what it's like, what is life at NetApp like? And usually that's mostly similar to many tech companies or many companies that you would work at. So Joe, you want to kick us off and talk to about what your typical day looks like?
Yep. So every job's different. If you guys have worked a job in, high school or middle school yet, or if you're in college, you may be kind of curious about what a job in tech is like. And so off the bat, I just like to paint the picture of, what I do on a typical day. We're going to talk about a lot of different jobs. Not everything is like this, but this is just a kind of a job shadow for what my day would be like. Also, typical days are not very typical anymore with COVID. A lot of what I'm saying here is what our days were like before COVID hit. So usually I'll start my day out with some coffee from the break room, and I'll start catching up on emails. Since we have a lot of automated code that's running every day, we get a lot of emails. So there's a lot of stuff to dig through. After I'm all synced up and I've had my coffee, we'll meet with all of our teammates, including everyone that's in this panel, and we'll have what we call a daily stand-up. And in that meeting, we'll just talk about what we did yesterday and what we're going to do today, and come up with our plan for the day. After that meeting, it's usually about just before noon, or it's at that. Sometimes that meeting will be at the end of the day, and then we'll have the rest of the day in front of me to write some code, fix some bugs with some code that already existed, or sometimes it'll be a different day and we'll be planning for the future on other projects that we're going to start. In addition to being at my desk or being up in meetings, a lot of times we'll just be out in the hallways, going to our coworkers, talking about problems, because there's a lot of technical details. So there's a lot of communication that happens back and forth, and it's very important to be able to have those quick conversations with each other. Nowadays, a lot of that happens over Zoom. But overall, from 9 to 5, that's about what my day would look like. So besides the day-to-day life, Apoorva is going to talk to you about at NetApp and what in other tech companies, what some other benefits of working in tech are like.
So if you saw Joe's day and you was a little worried about, how much work that you got to do, let me tell you that at NetApp or any other tech company, it's not always work. So we are at NetApp involved in a lot of other things outside of just our day-to-day job, and we have a lot of fun with our teams. So we get to spend a lot of time volunteering for various causes within our teams or independently, right? So we have a lot of affinity groups as well. I mentioned Women in Technology, YWIT, which I'm a part of. There's NetApp network of Black technologists and many more. So these groups aim to provide support and a sense of belonging within its employees. So we are also allowed, we have biannual hackathons. So if you also allowed to work on some fun projects, outside of our daily projects, so that we're a part of, where we make teams and we get together and create our teams and work or hack to solve different problems and interesting problems within our day-to-day lives or within our work as well. So we have so much fun also celebrating a variety of cultural events. So we've had Black History Month celebrations, Hispanic Heritage celebration, and also this weekend is Diwali, which is a festival, Indian Festival of Lights. So we are, celebrating all of that. Unfortunately, in the current COVID scenario, COVID world, all of these celebrations are virtually. So we do miss, hugging our teammates and hugging our coworkers at work and seeing them at work. But we try to do all of this virtually and still try to have a good time. So we get together with our team members, occasionally, and now with COVID, we play a lot of, virtual happy hours where we play Pictionary, Kahoots, etc. So we try to have fun with our team. We also try to get, in the pre-COVID world, we had quarterly, we go out on picnics, we go golfing, etc. So then a bunch of team outings that we do. And in post-COVID world, we have reduced the amount of people that go to these things, and we try to be physically distant and be safe with masks and and keep a distance from our employees. But that's how we have fun. at NetApp. So with that, we are ready to get into the main part of why we are here, right? So Joe, you want to take us through this?
Sure. So, you saw that the title for this presentation was, a picture's worth 1,000 jobs. So when we were thinking about how we would want to do this presentation, we came up with a lot of big questions that you guys might have about what it's like working in tech. What different career paths, what should I study? What are the things you work on a daily basis? And there's a lot of big, broad questions. So the way we wanted to talk about that was through an example. So the example we came up with was what happens on your phone when you take a picture. Well, there's a lot of different careers involved with that. There's actually thousands and thousands of people that work on the different parts of your phone to make the magic happen when you take a picture. So in this example, we're going to talk about 4 different career paths in more detail, and how these different career paths, how you can get started in them, what it's like, the kind of things you need to know, and what you might be good at to work at these kind of jobs. And then later, after going into depth with these 4 careers, we're going to talk about other careers as well that aren't specifically these 4, where you could still be involved with taking a picture or in tech in general. So first off, we have front-end development, and Denise is going to talk to you about that.
Right. Just take a quick pause, Q&A. So if you have any questions while we talk about this, please feel free to put it in the Q&A section, and we will try to answer them at the end of it. Thank you. Denise?
Okay, so front-end development. Before we get started there, though, let's take a look at the poll results. So the question was, when was the first cell phone released? And there were 4 answers shown, and the majority got it right. It was 1973, and the company that put out the first cell phone was Motorola. And the phone looked not like what you see today. It was more like the handset that you use if you have a landline at home, and it weighed almost 5 pounds. It's not something easily you could put in your pocket or in a purse or anything like that. So the cell phone has evolved over the years, and it's the technologists that are helping it to evolve. So the front-end development for a cell phone is something that a lot of people work on. And one person in particular that works on this piece is called the user experience engineer. And just like the name suggests, that person's role is to think about who's going to use the phone, how are they going to use it, and what are the things that are going to make that experience for that user the best possible. So this is a capture of an iPhone screen from where you take the picture. You see in the middle, that's where the picture view will be. And then all around it, there are buttons. There's the big button, that's the button that lets you take the picture. So that one obviously is the biggest one because that's the one that you're going to use the most. And then there's also buttons all around placed on the outskirts to not interfere with your view. And as you can see, there's an arrow pointing to this particular button. And that button is one that allows you to take a live picture. And so the process for the development and placement of that button is quite complex. It involves the user experience engineer putting on lots of different hats and coming up with a solution. And part of it includes marketing research. What do people want? Who are the users? What do they want? How important is it to them? And it's also psychology. What will they think if they see this button? Are they going to recognize it and think, oh, this is going to help me take a live picture? They also have to deal with the design. Like I said, the placement of the buttons on the screen. Is it one they're going to use a lot or a little? And also then they have to understand technology. What can they actually do? And so they get all that information, and then they go to meetings. As Joe talked about, there's meetings throughout the day, and they talk about their proposal, and they share it with the people on their team, and then the team works together. And once they agree upon the solution, then it's handed off to the next engineer to take over and actually implement that. So Motorola phone shown here is very similar, right? They have different user experience engineers, probably, maybe have a different market of users that they get feedback from, and so theirs looks similar, but there are some differences. And if you ever look at your phone and your friend's phone, you can kind of see differences. And sometimes when you want to do something, you're like, well, how do I do this? I know how to do it on mine, but not on this one. And so that's what makes the phones unique. And the careers, as I said, there's the user experience designer. There's also the mobile or web app developer that actually puts all the screen pieces together. There's a technical architect, which is usually a more senior person, and over the years they've developed skills so that now they can make some of the decisions and the final placement of all of those buttons on there. There's marketing people that deal closely with the people in the field and understanding what they want. And then there's the product manager, and that's the person that makes sure that the technology gets built and delivered in the time frame that they need for the customers. There are different learning opportunities that can help you become a person that's involved in the front end development. You can study computer science, information science in college. There's also a focus on human-computer interaction. What does it mean for a person to interact with a computer, and whatever computer that is, whether that's a phone or whether it's your laptop, whether it's a tablet, any of those, there's people studying that. And programming concepts and languages is very important in this area, because you need to understand what the concepts and the languages are that are going to help develop that solution for your customer.
Awesome. I think that was a lot about front end, right? So, but it's also a fun job. So let's get into Joe's part, where you'll understand how it works underneath it. Joe?
Yeah, so Denise talked to you guys about how the front end developer gives you a button so you can interact with the phone, and there's a lot behind that. But the next thing we'd like to focus on is what happens when you push the button. How does the phone mechanically work to actually take a picture? So part of that is the job of an application developer. So the application developer writes code to solve problems like this all the time. Apurva, Denise, and I are all application developers. So this is the kind of stuff we do on a daily basis. In the example with a phone, developers, they don't just go and write some code to take the picture right away. There's a lot of planning involved. So oftentimes our steps will involve planning how we want to do something first, then writing the code. And then after we write the code to make the picture work or something like that, we want to write tests to make sure that that code works all of the time. Overall, this process is kind of similar to building puzzles, like the big 1,000-piece puzzles with a picture on the box. You don't just take the box and then just dump it out on the table and put all the pieces together. That would take a long time. The first thing you do is you build the edges around, and that's sort of like coming up with a plan. You figure out where everything's going to fit. And then every time you add a piece to the puzzle, you go look at the picture on the box and make sure that the picture still matches. And that's kind of like your testing. So in these pictures I have on this slide, I've got the flow chart on the left and some example code Java on the right. Now, you don't need to understand everything about this, but these are just some pictures of tools that we use on a daily basis. The flowchart on the left is something that Denise, Apurva, and I would talk about. This is how we would plan how the picture is going to be taken on the phone. And the code on the right would be the actual code that makes the phone take the picture. And in this example, it starts at the top and it says, turn on the camera app. And then it continually checks the screen and draws the picture on the screen and makes the camera click and take the actual picture. And then finally, when you press the home button, it closes it. That's an example of how an application developer would put this code together. So if this kind of career is interesting to you, if these problems are interesting, there's a lot of different jobs out there. So in general, there's a lot of different jobs for application developers. The biggest, most common career paths can include mobile app development, which is making applications that run on your phone. There's web development that makes the web pages that you guys see. There's test automation developers. So test automation, you can write tests that test your web page or your mobile app or other things. Additionally, there's plenty of other software engineering jobs that use these concepts of application development. And that's the kind of job that Denise, Apoorva, and I work on. So if this stuff is interesting to you, the most direct way to get involved could be studying computer science or information science in college. But there are a lot of other opportunities for getting involved with this as well. You can learn programming languages for free online. There's lots and lots of resources out there. You may even talk about some of these or use some examples in some YWIT classes that they have. And additionally, there's certificates you can learn, and you can use those to get involved with other tech jobs. And that sums up application development.
That flowchart on the left did look a lot like Scratch programming. So if you have done that before, that looks very similar to our planning. So Joe, do you want to continue to the next one?
Yeah, so we just talked about front-end development and we talked about application development. There are still other tech careers out there. Being able to take a picture on your phone isn't everything. Apoorva, what do you do when you take a picture on your phone? You don't just let it sit there, right?
No, I probably send it to my friends. I usually take pictures to send it to my friends.
Right, so in this part, we're going to talk about networking. We're going to talk about how multiple phones connect together, or how phones connect to the internet and talk to laptops or anything else. So I've got a picture here that kind of summarizes at a really high level some different things that are involved in the internet. We're not going to understand the whole internet today, but we're going to walk through an example. So let's imagine Apoorva takes a picture on her phone, and then she wants to send it to me. When she does that, her phone talks to the cell phone tower, and the cell phone tower talks to Verizon. And then Verizon goes and talks to another cell phone tower, and that cell phone tower talks to my phone. And that's the high-level steps. Additionally, instead of sending the picture to my cell phone, the picture could be sent to a laptop talking to a router, or the picture could go to the data center in the top right. And you know, so after we've taken this picture on the phone, there's many different places you can send it. So networking jobs are very important. You can see there's a lot of big connections here. There's a lot of different people that have to work on all of these different layers. And because of that, there's a lot of different career opportunities for lots of different skills. So you could work in a job where you make cell phone towers that talk to phones. You could work with Verizon or another internet service provider in making that infrastructure. You could work on making the laptops connect to the internet, or you could do what we do at NetApp, and you could take the picture and store it in the cloud or in a data center. And broadly, the names of these career opportunities could be network engineers. They might make these devices. Network technicians, they might be the people you see working on a landline up in the tower, connecting everything together. There are other careers in telecom as well. Besides studying computer science and information science, there are other things you could learn in college. Engineering or telecom careers, they'll teach you everything you need to know about this. It's okay if you don't know right now. And there are other jobs where you don't even need to go to college to study these things as well. And being able to connect people together like this, there's a lot of different opportunities. So finally, we're going to go talk about a fourth career that's involved with taking a picture, and that's where you store the data. And Apoorva is going to tell you more about that.
Awesome. All right. So if you're like me, the picture you took, you just love to send it to your friends. So what happens? So the picture needs to be saved. Joe, where do you save your photos?
Well, I don't keep them on my phone. If I lost my phone, then all my pictures would be gone. I upload them to the cloud.
All right. So yeah, so that gets in. That's a good segue to our next point. So you could either save it on your phone locally, but like Joe mentioned, what if you lose your phone or, you know, just fell down the toilet? Happens to the most of us, the best one of us, right? So you don't want to lose all the memories that you've captured on that phone. So what do? You send it out to the cloud. If you are an Apple user, you would put it on iCloud. If you are an Android user like Joe and I, we use Google Photos or Google Drive to back all our pictures up. So what does saving something over the cloud mean? So you hear cloud a lot from all of us, right? So what exactly does it mean? So it just means that storing and accessing the picture that you took, and you're storing and accessing it over the internet instead of on your device. So you just heard from Joe about how the internet works. So it's just the same thing. If you want to send your picture over to your friend, storing it over on the cloud is just like sending the picture onto the cloud, so you can access it whenever you want. So this is a picture of a data center that Joe had earlier showed too. So, and on the left is a picture of a NetApp storage device. So it has a capacity, as you can see, is 176 petabytes. So I'm sure you've heard of like gigabytes or megabytes, but what's petabyte? Petabyte is huge, right? So it's 1 petabyte is equivalent to 1 million gigabytes. So think about this in terms of how much capacity your phone storage has. An average phone, let's say, has about 64 GB, right? If you go and maybe you'll have 128 or 256, maybe newer phones will have a little bit more, right? So 1 petabyte will have 1 million. So imagine the difference in how many phones that's going to be in that one storage system. So 176 petabytes, right? And that's equivalent to 10 billion megabytes. So consider an average size of a picture. It's about, say, 10 megabytes maybe, or a little bit more. If it's high resolution, you would probably say 50 or 60 MB. So that's, if you want to store that much, it's 62 billion pictures is what you could store on a storage system like this. And having said that, so that is just one box, right? And you will have data centers with thousands and millions of boxes like this. So it's just, we are at this point also generating a lot of data. The amount of pictures that we take on our phones day-to-day basis, and it's just pictures, we're not even talking about videos or any other data that we're generating. So all of that needs some storage. It cannot be stored physically on your device that you carry. If it's backed up in a data center on the cloud, it's more secure there. And if you lose your device, you will still have access and nothing will be lost. So the largest data center, this is a fun fact, it's about 6.3 million square feet, and that's in China. So to give you an example of how much that would be, it's about 100 football fields. So that's a huge data center, and that's just one. There are so many spread all around the world, and that just helps you, and that just shows you that storing data is very, very important, and having access to them at all points is also really important. So so let's get on to let's see some examples. So Joe, what's your favorite animated movie?
I think my favorite animated movie is Shrek.
Oh, awesome. I love Shrek too. So that's good. That's DreamWorks. So let's see how you would use how DreamWorks uses storage and data and NetApp and to kind of make all these amazing animated movies. So let me just turn that off and let me stop recording and let me, thank you for that. Awesome. All right. So if you like that, I'm sorry about the technical glitch there a little bit. So if you like to have a career in data, right? And we are software engineers, and this is where we come in as well. We are software engineers within a storage company. So we work on storage, but on the software side of it. So if this is something that's interesting to you, you could be like a data scientist or a data analyst. With amount of data that we generate on a day-to-day basis, you need some expertise in analyzing it. You need to know how to make the best use of it. That's where a data scientist would come in. As a storage administrator, you could be architecting storage systems based on a company's needs. Based on how much data they generate. As a hardware engineer, you could be making sure that the software works well on all the storage devices that your company has. So there are a lot of career opportunities there. So how can you have a career in data storage, right? So we have started off, there's a degree in engineering, CS, IS, and you can major in databases, data sciences, maths, and statistics. Statistics is very important when it comes to data analysis. So with that, you could also take up networking and operating systems. Those are some important courses that could help drive you in your career with software engineering. Right? So with that, Chuck, what if I don't like any of this?
Yeah, thanks, Apoorva. So, I mean, as you can see, any business and technology is no different. There's a lot of supporting pieces that need to go to place and roles for people to work and help. I won't go through all of these, but a few of them here. Cybersecurity, as you can imagine, making sure that that photo you take, it's not shared, it's secure, and only you can get to it, or the people you want to be able to see that photo. Things like law. As you come up with an idea for software, you could work as a technology or a patent attorney who would help you, put that idea in motion, and so that you own that technology and help you support licensing. There's a lot of different things for the law side of it. And when you look at managing the technology, there's a lot of things Joe pointed out all throughout, the flow of that photo, traveling from your photo to another, from your phone to another phone, or to the cloud. There's sales, marketing, the people that have to be the salesperson for that marketing. There could be people that are making commercials for Google, commercials for Apple, customer support. If you have a problem, if you ever used Apple Care, you had to call in, they help you with your phone. Those people need to understand technology in order to help you. Engineering management is kind of near and dear to my heart, given that's kind of my role right now. And I get to work with awesome people like Joe, Denise, and Apoorva, and work alongside them to create really cool new features for our software. Art, there are all the designs that go into this. Even on this presentation slide, you see there's art that's put into this to make it more interesting. The game illustration, we saw the DreamWorks video. There's a lot that goes into that. And then, of course, there's psychology, medicine, that all have technical aspects of it, which I think maybe, even Apoorva and Denise can talk a little bit more too.
Yeah, so last year at a Grace Hopper conference, which is the biggest conference of women in tech, I met this interesting young woman in tech who's a senior at Georgia Tech. So she grew up with a brother who was on the autistic spectrum, and she saw how his iPad was so dear to him, and he was able to learn so much and, just have a great time and enjoy. And it made him so happy being on his iPad and, working on all different apps that he got to use on there. So that kind of drove her, into getting into psychology and trying to understand how to make his life better and how she could combine technology along with it. So what she did is she took both those classes. She was majoring in psychology with minoring in computer science. And she was able to build apps that helped people like her brother who are on the autistic spectrum, and make these apps for people who are differently able, who don't see things the same way as a lot of us, right? So she also got to intern with Disney, where she built products called Accessibility, which basically driving Disney and making Disney's content available for a lot of people who are, accessible to people who are, differently able. So there is tech built into everything. So, if you're interested in psychology, you could potentially minor in something like this and do what she did and kind of combine the best of both worlds. So that's an example that I have. Denise, do you want to talk about what your daughter's up to?
Yeah, definitely. My daughter, as I said, is majoring in biomedical engineering. And before she went into that field, I didn't really know much about it. In the first summer after her freshman year, she got involved in a project to do 3D modeling for lungs. And actually, kidneys have already been researched, and there are already models using 3D technology of kidneys. And so moving to a lung is a larger and more complicated organ. And so she's working with people at her university on modeling that as a 3D lung, and figuring out how can you make this 3D model behave just like a lung would behave in a human. And that way we can learn more about the lungs and see how they react to different applications that they're placed under. And so it's really pretty cool. And she uses, as I said, the 3D modeling and 3D printers. She uses MATLAB. She uses a lot of different technology, even though technology isn't, you know, the core piece of her studies. It's still very much involved, and she's been programming in Python and learning Python, as well as doing the other parts of her biomedical study. So it's actually really cool to watch her do that and to see what technology is enabling.
Awesome. Well, with that, I think we are coming on to the end of our session. So we will go into some questions today. If you're not able to answer any questions that you may have, please feel free to drop some questions on the Q&A part based on the session you heard. If you have any questions about it, feel free to drop it in, and we will go over them and try to answer them. All right, so let's see. So we understand that it's a lot to take in, right? Coming in, if you're in middle school, or if you're a little bit younger, all of these things seems to be very difficult. But think about the classes that you've taken. Initially, everything seems like a Herculean task. It's like everything seems difficult. But the more and more you kind of work towards it, and the more and more there's internet, there's YouTube, where you can learn a lot of things. And it tries to become a little bit more easier. Whenever you start a new job, it's the same thing. When you start a new class and start a new grade, everything seems difficult at first, and then you can just get on with it, and you will learn it, and you will know more at the end of it. All right, so let's see. We have a question. So how is technology involved in mechanical engineering? Anybody wants to take this? Or I can take it. So have you ever been on a Tesla or any car which is released in the last few years or even more? You have GPS integrated. You have you have your rear end camera. You have blind spot detection. All of this is tech. So if you just look around you, tech is just built in to everything. So hope that answers your question. So the question was, how is technology involved in mechanical engineering? It is involved, and there is a lot of opportunities there.
Yeah, going back to the phone, someone's got to write the code to make the aperture on the camera change. That's a mechanical thing. And it's not just going to change on itself. Someone has to write the code to change that. And that's how technology could be involved.
Okay. So thanks, Joe. So the next question we have is, would it be hard to find a way to combine computer science with a topic that is far from it, like dance? Let me see if I can think of an example. Have you played Dance Revolution or any of these computer video games? Which is that game on the PlayStation that does any of you remember?
Just Dance, is that what you're talking about? I've played that many times with my kids. Both my son and daughter love Just Dance. We even talked about it at dinner the other night. So yeah,
awesome.
That's definitely an example of how you can combine dance with technology. I mean, there's a lot that goes in to that Just Dance game, in understanding where you're moving your hands and your feet and your head, and scoring you to see how well you did compared to what you watched. And there's definitely careers that bridge the gap between dance and technology.
I'm sure the professional dancers are coming up with those moves on Just Dance. It's not easy. Some of them, they're really hard. And I'm sure if there are dancers who work who work in that company to come up with that.
Yeah, I always lose. My kids always beat me. I never win.
All right. So, okay.
I'll take the question on video game creation.
Okay. Yes, Joe. So the question is, what kind of jobs are there in video game creation?
Yeah, there's absolutely tech involved in video game creation, for sure. So you saw the video with DreamWorks, right? In DreamWorks, the way that they built the movies was through constructing 3D models on the computer. So video games are very similar. You have 3D models that you may want to construct, and technology aids them in doing that. But additionally, with video game creation, a lot of times you want to make those video or those 3D models as fast as possible. So in tech, you might study ways to make that possible. You might study the math that draws the pictures, or you might study the hardware like a graphics card or a processor that is able to put the picture on the screen in a faster way. And those are just two examples. There's video games are very heavily related to technology.
Yeah. And you could be an artist who comes up with all of these, the game icons, or what are they called? The characters in a game. So they have to be designed, right? So you could be an artist who comes up with those.
Yep.
All right. So next question, interesting one. So is it true that, I think it means backend developers, is it true that backend developers have higher average salaries than front-end application developers? This is based off of careers I have researched. Chuck, you want to take this as an engineering manager?
Yeah, so I'm not completely up on the most recent information around the average salaries, but I would say that probably is true. There's a lot of complicated things that go on the back end of systems, like we explained and showed today. But that's not always true. Again, you have to look at the average of these salaries. If you work for a company like Microsoft and you're working on Microsoft Word or Excel, that's a front end technology. And my guess is the salaries, they're looking for the top people to help them make sure that they have a really rewarding experience for the user for things like Microsoft Word, Microsoft Excel, or if you're working on a particular app, like the iTunes app, I'm sure those are higher than the average on the front end. But in general, there probably is a little bit of a skew toward the back end being higher. But I wouldn't necessarily let that drive you if you're looking for a career path. You should find out what's interesting for you. And although salary is important, everyone knows that, making sure you enjoy what you're doing is the most important thing.
Right. Awesome. Thanks, Chuck. All right. Someone's asking, is it all right if I leave the meeting to eat lunch? Yes, please. Sure. I think you've come up to the end. You can go and have lunch. All right. So let's see. Another question. I'm interested in Chinese dance and researching Chinese dance history and discovering new forms from historic artifacts like arts and statues, and them communicating research with mainstream audience. Oh my God, that's awesome. However, I'm also interested in computer science. Do you have any advice on how I could pursue both?
I have an idea. Yeah. Worth mentioning. When I was in college, I majored in computer science and I studied a lot of machine learning. Machine learning is a pretty complex topic, but at a high level, it's trying to make computers do things that are like the things that humans do. So for example, when it comes to dance, computers are really good at processing images. If you look at history and historic artifacts from Chinese dance and statues, you can have a computer that aids you in understanding those. The computer can run machine learning to classify images. It can group similar images together. It can help you understand details of an image you might not have seen before. If you study machine learning in computer science, you might be able to learn more about Chinese dance and history than you would have been able to if you just studied it without computer science.
Yeah, I'll also add too, and again, using my daughter as an example, she goes to a college, Allegheny College, where they encourage people in college to find very diverse majors and minors. In fact, I think they'll steer you away from a minor that's too closely related to your major. So she majored in computer science and minored in communication. and they try to find a balance between more of the science and the liberal arts side of things. And I think that plays in well with what you're doing. And I think that's something that a lot of schools now are encouraging.
Yeah, I think great points. Thanks, Joe. Thanks, Chuck. All right, so we have one other question. Is it all right to not know what technology career you want to go into, but still be really interested in tech and majoring in computer science? Yes, absolutely yes. That is what school is for you to like understand, try out different things and see what you like the best, right? So like I mentioned my experience, I hadn't written a line of code until my undergrad, and that's when, and even 3 years maybe into it, I was still not sure which direction I wanted to go into. So it comes slowly. That's what school is for. That's what college is for. Take your time, try out a variety of things and see what you like the best. Anything anybody else wants to add on?
You'll experience so many things as you continue through high school and college, and you know, your experiences, again, you know, even like I said before, this experience shaped my daughter's next steps, and you'll hit these decision points along the way that you'll decide on new things, you'll experience new things, you'll talk to new people, and it'll help you start to see, oh wow, I want to do this, or this sounds interesting, and you'll start to, you know, take that path forward. So it'll all come together.
Yeah.
And don't be afraid to change. If you start in computer science and you think you want to try something that's different, or the other way around, don't be afraid to change. Having a breadth of knowledge instead of a depth of knowledge is absolutely a skill.
Yeah, they say that most people have 4 different careers that they have throughout their lifetime. Most people do not stay in the same area. You know, they stay in it for a little while, realize that they really like something else, and go and pursue something else. So don't feel just, you know, because you start down a certain path, you have to stay there. And most colleges give you access to so many things to learn about the different opportunities that you have. I was talking about my son and how he is applying for math and statistics. Even within the statistics department, there's 8 or 9 different tracks. You can focus on data science, you can focus on machine learning, you can focus on financial. So, you know, if you like Wall Street and the stock market, there's an avenue within statistics to focus on that. And usually when you start out, you don't need to pick which area you want to be in. And actually they encourage you to look and explore other areas. So there's definitely no pressure to decide, you know, the first day that you're in college, what degree you're going to have at the end or what job you're going to get. And there's no need to think that you're going to be pigeonholed there and that you can't do something else. There's definitely lots of opportunities that you can take.
Right. And I want to give an example of, you know, one of our colleagues, Twesha, who started out, you know, wanting to get a medical degree. And then well into it, she just did a tech project, and she built a website for a friend. And that's what got her interested into technology. And now she's a software engineer like all of us. So things can change. So it doesn't really have to be pick this lane or can't take anything else. Right?
And another interesting fact about Twesha is that she also takes pictures for her friends on the side, and you know, she has a website with all of her pictures, friends who've gotten married or for graduation, and she uses technology, right? So she takes the pictures and then she uses software to help her enhance those pictures. So even one person can have multiple different paths they're pursuing at the same time.
Awesome. Wonderful, wonderful question. So the last one, I think we are at the end of the hour. So the last question was, can I email the NetApp email address to follow up? Yes. If you have any questions still about, you know, tech careers or whatever it might be from this session, please reach us at ngywitquestions@netapp.com. Mention a picture is worth 1,000 jobs in the subject line so that the questions come to us. And at the end of this day, you will receive, your parents' emails would receive a survey link. Please work with your parents to fill those survey questions out and help us get your feedback on how the session went. Thank you so much for attending. Hopefully you have a wonderful rest of the day and great day of learning. Thank you all.
Thank you.
Bye, everybody.
Bye.
Bye.
Thanks for joining.